Lesson 7.6, Rentals, Condominiums, and Cooperatives. Please read the introduction article, What Alternatives Are There to Purchasing a Single-Family Home, to be familiar with the terminology that we will be using in this lesson. Example 1. Last year, Bert paid a monthly cooperative maintenance fee of $912. 15% of this fee covered his monthly property taxes. How much did Bert pay last year in property taxes to the co-op? So the first thing we want to figure out, this is his monthly fee. So monthly, how much of his property taxes was he paying? So we know that 15% of the fee is going to be property taxes. So 15% as a decimal is 0.15, and 50% of, means we're multiplying, of the fee, which is a $912 fee, ends up giving us that he is paying $136.80 per month in property taxes. But this is per month. We want all last year. How much did he pay? So this is 1 month. We want 12 months. So we want 12 months of property taxes. So 12 months of the $136.80 gives us a total of $1,641.80 of annual property taxes. Let's go ahead and check your understanding. Maggie's monthly maintenance fee is $M. This is how much she pays every month, M. 27% of it is tax deductible for property tax purposes. Express the annual property tax deduction algebraically. So the first thing that we did is we know her monthly property tax times the 12 months would give us her annual property tax. But what is her monthly property tax? Her monthly property tax is 27% of the fee. So what is 27% of her M? 27% is supposed to be 0.27. Of means we're multiplying, and you're multiplying to the M. 12 times 0.27 gives me 3.24 M. Example 2. The Seaford Cove Cooperative is owned by shareholders. The co-op has a total of 50,000 shares. Janet has an apartment at Seaford Cove, and she owns 550 shares of that cooperative. What percent of the Seaford Cove does Janet own? So Janet owns 550 of the units. And how many of those units are there? There are 50,000 units. So this is how much she owns out of what is total. Divide this, I end up getting the decimal 0.011. But it wants to know what percent does she own. So grabbing the decimal, moving 2 to the right, she ends up owning 1.1% of the co-op. Now let's go ahead and check your understanding. The Glen Oaks Village Co-op is represented by S shares. So there are S shares in this entire co-op. Sage owns R of them. Express the percent of shares that he owns algebraically. So we know that he owns R of the S total shares available. Divide this, I would have gotten my decimal, but I want a percent. Algebraically, how do you turn a decimal into a percent? You multiply it by the value of 100. So I have fraction multiplied by a non-fraction. If I turn this over 1, it's now a fraction multiplied by a fraction. Fractions get multiplied straight across. So this is 100R all over S is the percent algebraically of how much Sage owns. Example 3. Gary's job is relocating to a new city. He knows he will be there for at least 10 years. Gary's uncertain as to whether he should rent an apartment or if he should buy a home for the time that he's working there. He knows he will eventually turn back to his home city. Gary wants to compare the total mortgage costs to the total rental costs before making our decision. Gary knows that he can afford a monthly rent of $2,500. But if he buys, he can put $100,000 down and take out a $350,000 mortgage for 20 years at this APR. Create a spreadsheet similar to the one you created in example 4 of lesson 7.4 to assist Gary in making his comparison. So we're going to be needing to use a new formula. And why are we using this new formula? If you're living in an apartment for 10 years, chances are the rent is going to increase. And we are going to assume that your rent is going to be increasing yearly by about 2%. This is the equation that we are going to be using to represent what our yearly rent increase would be. R represents how much rent you've spent that year. A represents how much you spent on rent in the first year. B is going to represent the rate of increase, and we are going to do a 2% increase because on average they raise about 2% every year. D is going to be how many years have you been in there now? Are you looking at the 8th year you're in that apartment, the 10th year you're in that apartment, or the 2nd year that you are in that apartment? So first, what is the information that we're going to need to use? We're going to need to know that when you are renting, what is the initial rent and what is your yearly inflation rate? Formatting these, I'm going to bold, I'm going to center, and I am going to wrap text. So we are renting the initial rent. Initial is spelled wrong. Initial gets another I. The initial rent is $2,500, and we need this to be a money, so we're going to hit the dollar sign so that it's a money. The yearly inflation rate is 2. So this is the information that we have. What do we want to know? We want to know at the end of which year is your total rent paid for that year, and then we want a running total of all the rent. Formatting again. I want bold, centered, and wrap text. So at the end of the first year, and then we want this to say the end of the second year, but we want it to be a formula where I don't have to constantly type it. So we're going to say, hey, equal sign, so this is a equation. I want you to add one more year to the one before. And we're not putting dollar signs around here because I always wanted to look at the next one and then add. So if I click enter, and then I grab this cursor and I drag down, it will continue to go. I only want 10 years. So we're only going to look at the next 10 years. So I'm going to go ahead and delete the others because we won't need them. Our total rent for the year. So I'm going to have an equal sign. There's the yearly rent increase equation. It had a parenthesis where you're supposed to have your initial amount of your rent. And then it has another parenthesis that is the 1 plus the rate. And that last parenthesis is raised to an exponent. So I'm going to have it like this so it's easier for me to see. This first one is supposed to be your initial annual rent. I know my rent by month. So if it's going to be annual, that means I need 12 of these. So it's 12 times this rent. And that rent's not going to change at all. So I'm going to put dollar signs around it to say, hey, that initial rent is always going to be my first initial rent. The second parenthesis is the 1 plus, and then I have a little fraction in there. That fraction is the rate which is increased, and that rate that's increasing is not changing. So I need dollar signs around it to show that, hey, it's not supposed to be changing at all. And that's supposed to be divided by a 100. My exponent is supposed to be the year at which I'm looking at, and then minus 1. The year that I'm looking at is going to change depending on which row I am in. So there are no dollar signs there because I need it to change. We need to make sure that there is a multiplication sign between the two parentheses. Clicking enter. This is my initial rent. I want to grab the cursor and drag down, and you'll see the rent is increasing, and it's increasing at an inflation rate of 2%. It calculated it for you. Now, what's the running total for the rent? At the end of the first year, you only have your first year's rent. But at the end of the second year, you're supposed to take the rent you previously paid and add the rent that you paid for that year. And that's going to be the formula the whole time. It's going to say, hey, take the one before and add my new amount for the next year. Take the one before, add the new amount for the next year. So if we drag it down, the formula will continue to go. At the end of 10 years, this is my rent for that 10th year, and this is how much I paid total in renting for all 10 years. So this is the 10-year mark that we're going to be considering. Now, what about if you are buying a home? So let's go ahead and do the buy the home on this other side. So information that we need when we are purchasing the home. We need to know our principal. That principal is $350,000, and I need this to be a money, so we're going to click on the money sign. I need to know my interest rate as a percent, and that is 3.5. I need to know the length of the loan, and that is 20. So these are my I haves. So formatting, bolding, centering, and wrapping my text. This is the information that you need to use when calculating your mortgage. Now, what information do we want to know? We want to look at your payment number. Is this the first payment, third payment, fourth payment? We want to look at our beginning balance, our monthly balance, our monthly payment. We want to look and see how much money is going towards interest. We want to see how much of that money is going towards principal. And we want to know what our ending balance is. So formatting these, I am going to bold, center, and wrap text. So our first payment. The next one needs to say our second payment. I'm going to make this an equation, and I wanted to say, hey, always add one more to the year that you just completed. So it's now a formula, and I want this to be 10 years, but these are all in 1 month increments. So that means I need to go all the way down to 120. So go until you think you can finish it off at 120. Not far enough. That only got me to 75. I need it to be 120. And now I've gone too far. So let's go ahead and delete. All I need is 120 because that's what 10 years at 12 months per year would have been. So this would have been the row of information that I need. So let's go ahead and fill that stuff in. So my beginning balance, this is my current principal. So my beginning balance is what I currently own. My beginning balance is going to change every single time because we've paid principal. So equal sign to say, hey, I want you to look somewhere, and the new balance for the second month is always going to be the ending from the previous cycle. And you notice nothing turned up because this is empty. But this has an equation built into it. It's going to say, hey, look at the previous ending. So we're going to drag this all the way down. And it's all empty because we do not have anything in this last column yet. As soon as we do, this will populate. So back, our monthly rent. So equal sign because I'm going to use an equation. This equation is from example 4 from lesson 7.4. I have a numerator and a denominator. In my numerator, I have 3 parentheses that I am multiplying together. That last parenthesis has an exponent. So that first parenthesis is always supposed to be the principal because we're looking at our monthly payment. This monthly payment is going to be the same every single time because it's always based on how much you said you were going to use. This is never changing. So we're going to put dollar signs around it to say, hey, this is never going to change. The second parenthesis is going to be my rate, and that rate's never changing. So I need dollar signs around that to say, hey, you're never changing. That's supposed to be divided by 1,200. My third parenthesis is 1 plus the fraction of the rate divided by 1,200. But remember, that rate is never changing. So dollar signs around the rate that's never changing. Your exponent is 12 times how long your loan is. Well, your loan is always going to be the same exact length. So dollar signs around that. This is my entire numerator. So I need to put parentheses around it so the whole thing is going to stay in the numerator. Now I need division because now comes my denominator. My denominator has a parenthesis that is raised to an exponent, and that whole thing is minus 1. I need to make sure this entire thing is in the denominator, so I'm going to put parentheses around the entire thing. That first parenthesis is 1 plus my rate that is not supposed to move at all, divided by 1,200. My exponent is 12 times the length of a loan that is not supposed to move at all, so dollar signs around all that, and then minus 1 is already there. So I forgot you're supposed to have multiplication signs in between your parentheses so the computer knows that they're being multiplied together, and hitting enter. This is my monthly payment. This should be the monthly payment for every single month. So if I drag it just a little bit, I confirm. It's the same exact monthly payment for every month. So we're going to go ahead and drag it all the way down to our 120th payment. So every single month is the exact same payment. So going back up to the top, now we need to figure out how much is your interest. Again, this equation is from example 4 in lesson 7.4. So equal sign says, hey, I am going to come up with an equation. Our interest is always based on how much we still have in our balance. So it's always going to be based on this spot, and it's going to change every time. So row 3 needs this row 3's balance. Row 6 needs this row 6's balance. It's always changing, which means there's no dollar signs around here. And I'm supposed to multiply this by a parenthesis, which means I need a multiplication sign to say, hey, you're multiplying to the parenthesis. Inside that parenthesis, I'm supposed to have the non-changing rate, so I need dollar signs around it so it's not changing, and that's supposed to be divided by 1,200. This is my interest, and if we go ahead and drag it all the way down, we will find the interest for every single month for all 120th months. And they're zeros. The reason why they are zeros is because they all rely on this balance, which we don't know, because we still don't know the ending balance. These will repopulate as soon as we know our balance, and that'll populate as soon as we know our ending balance. Our principal. Your principal is always what is left of this paycheck after you took out the interest, and that's changing every time. It's always going to be this cell minus this cell minus this cell. So no dollar signs because it's going to be changing. Again, we need to drag it all the way down, so this works for all 120 of our payments. And notice that they're all the same. The reason why they're all the same is because they rely on this, and we don't know this yet. Our ending balance. Your ending balance is always your beginning minus how much went towards the initial principal. And this is always going to change. It's going to be beginning minus principal, so no dollar signs. So here it is, and we're going to drag this all the way down so it counts for all 120 of our payments. And because we finally had him, everybody else populated. So this was our 120th payment, which this is the information that we end up needing. This was our total interest. This was our total principal. And I want to know how much have I paid total in interest. Equal sign. I want to add up all the money in here. So I'm going to type in sum, parenthesis, and I am going to go through and I'm going to highlight everything that I want it to add up, and I wanted to add up this entire column. Stop there, close my parentheses saying I am done, and I think I accidentally hit a 0. Close the parentheses so I can say that I am done. Hit enter. This is how much I have paid in interest total over 10 years, over the full 10 years. Do that for principal. Equals sum, parenthesis. I wanted to add up everything I paid so far towards principal. Stop there because that's where I wanted to end. Close my parenthesis, enter. So at the end of 10 years, if I purchased a house, this is how much of it went to interest, and this is how much that I had paid towards principal. This is how much I still owe on the home after 10 years. Let's go look at the rent. After the end of the 10 years, this is how much I have paid total for 10 years worth of rent. So on our spreadsheet, we found a couple of different items. We observed that rent after 10 years, that you ended up paying $328,491.63 in rent if you lived there for 10 full years as a renter. We noticed looking at your mortgage for 10 years, mortgage for 10 years takes into account both the paid interest and the paid principal. This is how much money I handed to the bank over 10 years. 10 years worth of interest, 10 years worth of principal. In total, I handed the bank $243,583.09. This is how much I paid when I was owning the house. If I purchase the house, I still owe money. And how much did I still owe? According to the spreadsheet, I still owed $205,272.91. I still owe this to the bank because that's how much of my loan is still there. That's something that we need to be aware of. When you own a home, you have what's called equity. I put $100,000 down on that home, which means I can get that $100,000 back. The principal, how much I've paid, if I were to sell my home, I would also get that amount of money back, which means the equity in my home is $244,727.09. Equity is how much money I would get if I were to sell the house. So if he's truly going to be there for 10 full years, it would be better for him to actually buy the home because of how much equity is there. This is how much he has paid total in the purchased home. But this is how much he would get back. Notice it's almost close to 0. After 10 years of renting, this is how much he's paid, and he gets nothing back if he were to move out of the rental. But for every year that he continues to own the home, the equity just gets bigger and bigger and bigger. And so he's making more money. So if Gary truly stays for 10 full years, buying is going to end up being better because of the equity on the home. Yes, he ended up paying this much in total, but if he sold it today, this is how much he would have made in return. He didn't lose any money whatsoever. But if 10 years of renting went by, this is how much he would have paid and never would have saw a dime. So owning a home after the 10 years would have been a lot better than renting. Now let's check your understanding. Make a list of other yearly costs Gary might have to consider in making his decision. How much you pay for rent and how much you pay for mortgage is not the only thing that you have to consider. When you are renting, you still have to pay for your utilities and you still have to pay for renter's insurance. When you're owning a home, you also pay for insurance, you also pay for the utilities, But on top of this, you also have to pay for the upkeep of the actual house while renting. The landlord does it instead. If you buy, you also have to take into account the closing cost, how much it costs to actually just buy the home to begin with, the closing. Example 4. Jake and Gloria moved into an apartment and they pay $1,900 per month. The landlord told them that the rent has increased 4.1% per year on average. Express the rent Y as an exponential function of the year number X that they are living in the apartment. And X equals 1 is going to represent the first year they're in their apartment. X equaling 2 is going to represent the second year in the apartment, and so on. Determine the amount of rent that will be needed for the 13th year. If you remember from Algebra 1, you have an exponential growth formula, and that is Y equals your initial value, 1 plus your increase rate, and this is to the time of t. So we have Y equals our initial value is how much we have at the very beginning, 1,900. 1 plus, they told us our increase rate was 4.1%, but that needs to be a decimal. So 0.041. And our time. We do not have a rate increase if we are on the first year. So that first year doesn't count. So we're going to minus the first year. So if I put an X value of 2, my second year, 2 minus 1 is 1. So we only have one rate increase. That's why the X minus 1 works. Now I want to know the 13th year. This is the equation I will be using. The 13th year says when X equals 13. So we're going to use this equation and we're going to solve for when X equals 13. If X is 13, that means we have had 12 rate increases, which is why the exponent works the way it does. Typing this all into Desmos exactly the way it is, I get 3,077.2469, which needs to be rounded. So you have about $3,077.25 is how much you're going to be charging each month on the 13th year. Now let's go ahead and check your understanding. Suppose that Jake and Gloria's rent went up only $60 per year. It's not a percentage, it's an actual value. If Y represents the rent and X represents the number of years, express their rent as a function of X. This is not a percentage, so this is not going to be exponential growth. This is actually going to be linear. This is Y equals MX plus B. My rent started at $1,900 and it increased $60 per year. So the increase, my increase per year was $60. And I started with an initial payment of $1,900. If X was 0, this would have been 0, which meant there was no pay increase after the first year. The first increase would have been $60. The second increase would have multiplied together to give me $120. So this equation right here represents the equation for only $60 increase every single year. Now let's extend your understanding. Explain why the sequence of increasing annual rents in example 4 is considered a geometric sequence. So there's both arithmetic and geometric. Arithmetic sequence says that you are adding to get to the next one. Geometric says that you are multiplying to get to the next one. So if you increase at a percentage rate, you were a geometric. If you increase the flat rate every single time, you were arithmetic. So example 5. The monthly rent for 2-bedroom apartments at the luxury Cambridge Hall Apartments for a 9-year period are given in this table. Find and use an exponential regression equation to predict the rent of 2019. Round all calculated regression equation values to 3 decimal places. Round to the nearest cent. We're going to type this into Desmos. And this is going to be represented by year 1, 2, 3, 4, 5, 6, 7, 8, 9. My 9 years that it told me that I had done. We're not going to write the years because it's going to make your calculations a little crazy. And we're looking for an exponential regression line. So it's a Y equals some value times your B to the X power, where your B is your increase rate. So let's go ahead and take a look at Desmos. So on Desmos, I went ahead and typed my table into the exponential regression function. And down here, I will notice my A value and my B value. These are the A's and B's that I am going to end up using for my equation. So according to Desmos, my initial value for A was 2297.78. My value for B is 1.05. and I'm supposed to raise it to the x exponent. And then it's asking me for the year 2019. So if this was 16, I know that 17, 18, 19. This would have been year 10, 11, 12. So I'm looking for an x value of 12. So plugging in an x value of 12 into the given problem that we found, I would have found y to be $4,126.64. Now let's go ahead and check your understanding. Examine the regression equation that we just found in example 5. This is our equation that we just found. To the nearest of a tenth percent, what was the approximate annual rent increase? This is our increase, and remember, this is supposed to be this exponential increase function. So I know that the equation 1 plus r is the same thing as 1.05. So we're going to go ahead and solve for r, and it wanted a percent increase. So moving this over 2 to the right, I have my r being 5%. My rent increased by 5% every year. Example 6. In the early 2000s, the price of cooperative apartments soared until the economic regression in 2009. In 1995, Ruth and Gino bought a co-op for $98,000. They borrowed $75,000 from the bank to buy that co-op. Years have passed, and now they want to sell the co-op, but the market value has dipped to $61,000. Their equity was $6,744. Equity means that's how much money they would get to keep if they sold. If they sold the co-op now, they would have to pay off the mortgage. How much money did they need to pay the bank back? So the first question we need to figure out is, first, we know that we borrowed $75,000. The money that they put into the home is $6,744 because that was their equity. That means if I subtract how much they borrowed from their equity, that I will know how much they still owe the bank. So $68,256 is how much they still owe the bank. If they now go and sell the co-op, if they sell the co-op for the $61,000 that it currently budgets for, it says it's the market value for $61,000. If they sell it for the value that it was at, this is how much they currently owe the bank. This is how much they would get if they sold it. That means $7,256 is what they actually still owe the bank now. So right now they owe the bank $68,000. I sell my house. I get $61,000. I still owe the bank $7,256 after selling.